Hey everybody! Today we're going to work on graphing systems of inequalities. So yeah, let's jump right into it. So basically we're going to graph two systems, two inequalities, and see what the area they shade in common is, and that's going to be our solution. So first one is y is less than negative 1/2 x plus 3. So 3 is our y-intercept, and our rate of change is negative 1 over 2. Let me zoom in here actually a little more. So we're going to go down 1 over 2. And down 1 over 2, and we're going to go up 1, left 2, and up 1, left 2. Now we're going to connect these. It's going to be a dotted line because it's non-inclusive. So this is a solid line, and this would be a dotted line. Okay. So we're going to go ahead and plot that. Oh, I totally screwed up. It should be dotted. Here we go. So it's a dotted line, there we go. And we still have to use a test point, so we'll test here, see if that shades. So y is less than negative 1/2 x plus 3. Actually, I'm going to use a pen so you can see that a little better. So y is less than negative 1/2 x plus 3. We're going to plug in 0, so 0, because our test point is 0, 0, less than negative 1/2 times 0 plus 3. Okay, so 0 is less than, see this is going to be 0 plus 3, 0 is less than 3. Is 0 less than 3? No, that's false. So this is going to be shading this way. We're shading this way, away from the test point. Okay, this other one is y is greater than or equal to 1/2 x plus 1. So 1 is our y-intercept. So I'll erase the test point now. Okay. Rate of change is 1/2, so up 1 over 2. There. Up 1 over 2. And then down 1, left 2, and down 1, left 2. And this is going to be a solid line because it's inclusive. So we're going to... This is a solid line this time, not dotted. And now we need to use our test point again. So here's our TP. So y is greater than or equal to 1/2 x plus 1. We're going to plug in 0 for our x and y because that's our test point. 1/2, plug in 0 for that. So 0 is greater than or equal to 0 plus 1. 0 is greater than or equal to 1. That's a false statement. So that means we're not going to shade towards the test point. We're going to shade away from it. So we're actually shading this way. So this is what they have in common, right here. Because that's where they both shade. Okay. I'll do one more. I don't want to do too many of these because I want us to do these on our own. Let's try one more. Let's do this one. So the top one, the y-intercept is 3. And the rate of change is negative 2, so I go down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1, up 2, left 1. And it's going to be a solid line because it's inclusive. And let's use a test point right here. So let's see if that works. So y is greater than or equal to negative 2x plus 3. Plug in 0, 0 for our x and y. So 0 is greater than or equal to negative 2, parentheses, plus 3. Plug in 0 for our x value. So 0 is greater than or equal to 0 plus 3. 0 is greater than or equal to 3. That's a false statement, so which means we're going to shade away from it. So we're shading that way. And the other one is going to be y is less than the negative 2/3 x minus 1. So this is non-inclusive. So the y-intercept is negative 1. The rate of change is negative 2/3. So down 2 over 3, 1, 2, and then over 3, 1, 2, 3, right there. Then 1, 2, 1, 2, 3. 1, 2. Okay, it's off screen. And it's a dotted line. It's non-inclusive. Okay, we use the same test point. So we're going to have is less than negative 2/3 x minus 1. Plug in 0 for x and y. Negative 2/3. Plug in 0 for x. Zero is less than 0 plus 1. 0 is less than 1. That is a true statement. So that means this is shading towards a test point, which means this is the area they have in common. There you go. Let me zoom out a little bit. So hopefully that helps. Make sure you're using a pencil, or if you're doing this digitally, which folks working at home, yeah, it's going to be tricky using it digitally. You're going to have to use the PDF editor. But all right, let me know if you have any questions. Thanks, guys.